SymPy is a great tool for symbolic mathematical operations, but it's not really efficient for other applications. So we will obtain a faster implementation without SymPy if we go back into the time domain and write our polyphase matrices as polynomials with matrix coefficients. So this is what we are going to do here, where a, n, and bn contain all the coefficients of z to the power of -1, and capital NA and capital NB are the length of the polynomials. So we see here capital NA, capital NB, the length of the polynomials AN and BN. There's a mistake here. Let's just quickly fix. And then their product is given here. Remember that a0 plus a1 to z to the power of -1 times b0 plus b1 z to the power of -1 is given by a0 b0 plus a0 b1 a1 b0 times z to the power of -1 plus a1 b1 times z to the power of -2. Observe that in the z domain, this is a multiplication of matrix polynomials. In the time domain, this is a convolution of matrix sequences. So now what we can do is to write a Python function that will be called polymatmult. So it multiplies two polynomial matrices, so the arrays A and B, where each matrix entry is a polynomial itself. So those polynomial entries are in the third dimension. And the third dimension can be interpreted as containing the coefficient matrix of exponents of z to the power of -1. So this is what we're doing. We're defining here this function to do the multiplication of matrix polynomials. And we will use this later.